Welcome to the fourth video in our Digital Twin series. In the last video, we learned that connectivity in digital twins is about creating continuity and accessibility by enabling bidirectional information exchange between physical and digital counterparts of an asset or system. In this video, the topic that we will be diving into is optimization and learning. We will be discussing learning in the context of machine learning. Optimization consists of fine-tuning a process in order to determine the most effective use of variables within a specific set of parameters. It is most often used for minimizing cost and maximizing throughput and/or efficiency. Machine learning is a method of data analysis that falls under a branch of artificial intelligence, which refers to the concept that systems can learn from data, identify patterns, and make decisions with minimal human intervention. What is the role of optimization and learning in digital twin? Our centers, C4NGL and C4NGP, have established a framework describing the 4 dimensions of digital twin. Analysability of a digital twin is about how models are used to make smarter decisions based on the needs of decision makers. Currently, the needs for optimization and learning are secondary to that of evaluation, as today's level of technology still largely depends on the human element in decision making. Analysability of a digital twin can be divided into 3 main levels, namely evaluation, optimization, and learning, which can be further broken down into simulation-based evaluation, simulation-based optimization, and simulation-based learning. Under simulation-based evaluation, the fundamental purpose of using a digital twin is to evaluate one or more scenarios and collect important statistical information for decision makers. There are 2 types of simulation-based evaluations. Scenario-based evaluation is evaluation made purely based on scenario input, which refers to data collected from sensors or the database. Optimization-embedded evaluation involves the incorporation of intelligent algorithms to help decision makers compare not only among layout designs, but also operational rules. The next level of analysability in digital twins is simulation-based optimization. Ranking and selection is a simple form of decision making. For example, determining the best port or warehouse layout or choosing the best combination of equipment. On the other hand, large-scale search involves the decision-making of design problems with parameters. For example, identifying the optimal number of trucks or automated guided vehicles in a fleet. The final level of analysability is simulation-based learning. Simulation analytics is the process of learning to form a rule between a scenario and the optimal decision under the scenario in order to generate a faster reaction in real time. Conversely, surrogate model is about learning from simulation evaluation, using it to replace the simulation model in order to achieve faster evaluation results. At our centers, C4NGL and C4NGP, we focus on simulation-based optimization and simulation-based learning. Simulation-based optimization is the linkage between optimization and simulation. By using a simulator to evaluate optimization results, the optimization's output is a final optimal decision. Simulation-based learning identifies the mapping between the scenario and the optimal designs under respective scenarios. It involves integrated consideration of sampling and evaluation of scenarios, designs, and replications. Our center's Autodesk, a software framework which stands for Object-Oriented Discrete Event Simulation, is the engine that drives simulation modeling in our smart digital twin. This framework provides our engineers with an accessible toolkit to build easily applicable discrete event simulation models for a wide range of industrial systems. Autodesk embeds optimization algorithms and techniques so that the digital twin is capable of mirroring complex real-world systems, as well as facilitates and supports decision-making on all levels. With data input from the entities and activities involved, Autodesk simulates various scenarios in order to generate a wide variety of results within different sets of parameters, during which the optimal result is identified as the default along with all other possible alternatives. All of these results will be used as data input, plugged into machine learning so that it may learn from them as a protocol of sorts, which the machine follows when it encounters any of the scenarios described in the generated Autodesk results. To put it into context, for instance, to find the best possible route to get a shipment from point A to point B, Autodesk would eliminate the need to obtain data via real-world trial runs. Instead, it would simply require an initial data input about the entities and activities involved, before simulating all possible routes and identifying the optimal result needed. These results are then used as data input for machine learning. The machine will then learn which is the optimal route to take by default. In the case that it encounters any deterring factors, such as weather, obstruction, or traffic, it will then take an alternative route that it has been taught to. Instead of relying on historical data as is done in traditional machine learning, Autodesk allows us to use simulated future data, which describes scenarios that may or may not have happened yet. This makes our technique applicable to situations where historical data may not be present or enough. Due to the availability of both historical and simulated future data, our machine is smarter, adaptable, and more independent than others. Granularity is another advantage of using Autodesk, as it allows users to build simulation models with varying levels of detail. The levels range from the least detailed with conceptual models to the most detailed with exact engineering protocols. Based on the level of detail required by the user, the corresponding simulation model with the right level of granularity will be used. Keep an eye out for our next video on visualization in digital twins. Find us on our websites and stay connected.